Hi, in this video I'll teach you how to find point of intersection of two lines. Let's start with one example. Find point of intersection of two lines in R2, one given in the standard form, the other one is given in the parametric form. Well, if this is the case, we have exactly same situation as the intersection of a line and plane in R3, meaning that we have to apply exactly same steps as we did there. So you can watch the video for the point of intersection of a plane and line for this example. Later in this video, we will see there might be other situations also. So step one here is that, well, write the parametric equation. So parametric equations are already there. So x equals to minus t plus 4 and y equals to 3t minus 7. Step two is that, well, these are, if these intersect, the coordinate xy that we have here should also satisfy the equation for the other line. This is point of intersection. So it means that plug in these guys, x into the x and y into the y of the other line. So it means that I have 2 times minus, sorry, let me do it with the, so 2 times minus t plus 4 plus 3t minus 7 is equal to 4. Well, you can simplify. Negative 2t plus 8 plus 3t minus 7 is equal to 4. And then this is just t plus 1 equals to 7. Step 3 was solve, find the t. So we just continue solving, and here get 3t is equal to 3. 3 is the value of the parameter of the point of intersection. So we have the point of intersection. Step 4, if we plug in t equal to 3 in the equation. So plug t equal to 3 in the parametric equations. Well, in this case, well, we just need to put t into those ones. So x is going to be minus 3 plus 4, and y is going to be 3 times 3 minus 7. So this is 1, this is 2. So that means that we have point of intersection, which is 1, 2. Well, as I said, when you have one parametric and one normal standard form, then you can do these steps. But how about the case that the lines are in parametric form? This can be both in R2 or in R3. It can be in both of them. Okay, so this is then new case that we have to learn how to deal with. So in this case, both of them are given in parametric equation. What you need to do first, make sure to use different parameters. In the parametric equations of the lines. So use, for example, use t in one and s in the other one. Why? Because the way the lines are parameterized by these parameters might be completely different thing. One can go fast, the other one can go slow, but these can be complete, so they don't need to be the same thing. What needs to be the same at the intersection point is that the coordinates of that point should satisfy both equations. Well, it means that set the corresponding coordinates of the two lines equal to each other. Meaning that, well, pick the x coordinate from 1, which depends on t, and set it equal to x coordinate from the other one, y coordinate from 1, and y coordinate from the other one. One is in s, the other one is in t. So these are just different equations. Now that you have those ones, you can solve those equations. Step 3, solve the equations for either s or t. For s or t, doesn't matter. What you need to do is use one of the equations to find t in terms of s, plug in that value of t into the next equation, and then find value of s in the other one, or the other way around. When you find that parameter s or t, then you have the parameter of the point of interception, then plug the parameter value found in step 3. So if you have found value for s, plug it into the equation in terms of s, and if it is in terms of t, you plug in the equations in terms of the t. So plug the parameter value found in step 3 into the corresponding equations to find the point. That's it. So you plug in that value and then you will find it. Well, let's just see how this works in an example. Find the point of intersection of lines x equals to 2t plus 1, y is equal to 3t minus 2, and the other line is x equals to 3, 5 plus t negative 2. Well, you see that both of them are parametric. By the way, this can be in R2 and R3, doesn't matter. Here we notice that, okay, one is in parametric form, the other one is in the point parallel form. We can turn this also into parametric form. So this is step 1. Well, this is x equals to 3 minus 2t, and y is equal to 5 plus 2t. Well, those ones are 2t plus 1, and y is equal to 3t minus 2. If you start working this way, you're going to be in trouble. Remember, you have to use different parameters. So for the second one, let's just use s instead of t. So we use 2s and 2. Okay, nice. That's step 1. Step 2 is that set the corresponding coordinates equal to each other. Because then the point of intersection should satisfy both of the equations. So it means that 2t plus 1 is equal to 3 minus 2s, and 3t minus 2 is equal to 5 plus 2s. Well, use one of these ones, and then we now want to solve this equation. Step 3, solve it. How we solve it? Use one of the equations, write t in terms of s or s in terms of t. I'll do the t in terms of s. It is, I'm taking 1 to the other side, so 3 minus 1 minus 2s. That means that 2t is equal to 2 minus 2s. Divide both sides by 2, you get 2 equals to 1 minus s. When you have that, take it and plug it into the other equation. So for t, we can write 1 minus s minus 2 equals, so this is this equation plus this one. For t, I put 1 minus s, and then the right hand side is 5 2s. Well, this is 3 minus 3s minus 2 equals to 5 plus 2s. And then try to solve this. This and that gives us 1. So minus 3s minus 2s equals to 5 minus 1. Okay, and this means that minus 5s equals to 4, and that gives us s equals to 4 over negative 5. And when you have that, step 4 is find the point. Well, this is just a parameter. Pick that parameter and put into the corresponding parametric equation. So it will be x equals to 3 minus 2 times negative 4 over 5, and y is equal to 5 plus 2 times negative 4 over 5. These are a little bit